Hello everyone, welcome to part 1 of my series of backtesting in Python. So in this video I'm going to show you how to use maybe the simplest backtesting framework in Python, Backtesting.py. It's very lightweight, simple to use. The code is on GitHub. You can do backtesting, backtesting.py, and you can understand the code and see what it does in certain circumstances. So that's very, very useful. So let's get started. This is part 1 of my series. In the other videos, I'm going to talk about backtest optimization, trying to optimize parameters, but that of course leads to the very dangers of backtesting, because most backtests are flawed because of the selection bias on multiple tests. So you conduct 1 million backtests, and of course you just use the good results, but you didn't tell anyone that you took 1 million tests to get there. It's like having a lottery, 1 in 14 million chance, and you try 7,000 tickets and then you come up with this magic formula for a winning ticket. It doesn't work that way. You have to basically show how many times you tried. And there's also the 7 sins of investing by Deutsche Bank. There's things like survivorship bias. There's things like look ahead bias. All these things that can very influence your backtest and mistakes that can be made. So I'll make a whole video on dangers of backtests. And then I'm going to talk in depth about backtesting metrics like the Sharpe ratio, Sortino ratio, drawdown, column ratio, and all that stuff. We're going to connect it to live trading with interactive brokers, and we'll also probably touch on options with backtesting. So that's what I have. If you want more videos, please suggest the topic, like and subscribe, and let's get the show on the road. Okay. So the goal in this video is basically I want to show you how to use backtesting.py to perform backtesting. I want to say that there's a lot of good videos out there for backtesting.py. For example, there's a guy named Chad Thuckleberry or whatever. He has a really good thing on backtesting.py. If you Google backtesting Chad, I want to sort of do it a little different than the other YouTube creators. I want to focus on things like, let's say, trade management, adjusting take profit, stop loss, canceling orders, things like that. So I want to make mine slightly a little different. And of course, being that I specialize in connecting it with interactive brokers, mine will also do those types of things. Okay, so just as an aside before we get started, is there are many frameworks for backtesting in Python. Vector BT sounds like the most popular one today. It's like a super quick based on Numba, and they have it's super quick. You can do many backtests. It's really fast. They focus on a paid version, which I heard is very good, by the way. But because it's much easier, in my opinion, to start with backtesting.py, I thought it was better to do that because it's readable, the code. There's also Backtrader, was used a ton, but the guy who made it doesn't maintain it much. Part-Time Larry spoke about PyAlgo Trade, but it's now depreciated and became Basana. There's Zipline that was using Quantopian, and also Steven Jensen's book, Machine Learning for Algorithmic Trading. Quant Connect, people say a lot of great things about. And also one of my subscribers told me about Nautilus Trainer, which is like an event-driven backtest, like an asyncio type thing, which actually seems like the IB in sync videos we do, so it might be the most natural. But anyways, backtesting.py is the simplest, maybe also because it doesn't interact with your brokers. A lot of these give you interaction with your actual broker. This one doesn't, so it's much simpler. I think you need to understand your own interaction with your broker. So anyways, let's get started. Okay, so backtesting.py is a bar level backtesting framework. It means whenever a new bar comes in, we need to make a decision. It's a framework where you get all these beautiful graphs and analytics with it. You can run the backtest and optimize it. We'll talk in the next video about optimizing the backtest. But of course, because it's a bar level framework, there's a lot of assumptions that need to be made, especially if you have limit orders, take profit, and stop loss orders. Let's say in the same bar, you have a limit or buy order, and then attached to that is a take profit and stop loss. So what if the low price is below the limit, but the low price is also below the stop loss price? How do you know what happens first, the limit or the stop loss? So just to give you guys a little heads up, if you look at the code, for example, Backtesting.py takes like the most pessimistic approach. So if I do pessimistic, so in cases where you have, let's say, the stop and limit within the same bar, we pessimistically assume the stop was hit first. So like there's things like that are a weakness of a lot of these backtesting bar level. But since most of us do things on a bar level, I think it's useful. If you want more accuracy, you can use smaller bars, even if you're basically computing things on a higher time scale. You can still use smaller bars just for precision on when the stop loss and take profit was hit, but only like make a trade like at the end of a bar or something. Okay, I'll show you how to do that in another video. Okay, so let's get started. Enough with me rambling. Okay, what we need to install backtesting.py. So pip install backtesting, and we also need pip install pandas TA, just because we're going to use that for doing things with technical analysis. So I'm going to install these two packages. Okay, and then I'm going to actually want to get a data set. I have, let's say, a 5-minute data set with AMD. As I said previously, it's probably better to use like a 5-second data set, even though you should you can compute your you can compute your indicators on a 5-minute level, but just to keep the granularity to make it more accurate, it takes a lot longer, but it's useful. So first we're installing these. So look, I'm installing these things. Okay, so now I'm gonna go here, upload my CSV file because it's Google Colab. Okay, and let me read in the file. So import pandas as PD, df equals PD dot read CSV. It's not called AMD, it's actually called df5 mins, I think. What did I call it? df5 mins. So I actually don't want it like this. I want, if I just do .csv, I get it. This is an object column, but I need to do like index call. I want the index to be the date. I can do equals 0, but I also can do this, and I can do parse dates equals date. So now if I click this, I have df like I want. Okay, great. So teaser example 1. I just want to show you like how it is in a big picture. So the big picture is you have a strategy class, which is where you put your strategy. And in the strategy class, like it's basically what you do in your strategy. You have like a next method that says like when RSI is like oversold, overbought, that sort of thing. You have this amount of positions, you're long, you're short, do this or that. That's in the next method. When a bar arrives, what decision are you going to make? So that's basically what the strategy thing is. So you subclass a strategy, and on the strategy, okay, so you define a strategy by subclassing the strategy class, and then you define your actual backtest. So you do like BT equals backtest, and you give it a data equals data frame, and then I guess it remembers my last notebook. So I give it a data equals data frame strategy, whatever I call that strategy. Did I call it simple RSI strategy? Cash is the amount of cash you start with. Commission is the percentage of the trade you pay in commission. So I want to say there's also leverage. You can do leverage, like there's a thing for leverage, and there's also a thing you can configure for slippage, which means like let's say you have a market order, how much the fill price is going to be worse than you expect. But I prefer not to use these things because like the assumptions, this is where you really need to make your own assumptions, because like if you're using, let's say, a broker like Interactive Brokers, they're kind of ruthless when they when they liquidate you. So like you really should use a reasonable assumption for a lot of these things. Like let's say you have leverage and the price goes down, they liquidate you always at the lowest price, which is annoying, but that's life. So this is how you define your backtest. You do like BT equals backtest, your data set, your strategy, how much cash, and the commission. Okay, so now we run our backtest. So how are we going to run our backtest? We are going to basically we're going to literally just do bt.run, right? And we can save it because it gives us a summary. We can save it into like a summary variable. And if we look at it, we see our results. Our results are, we get a lot of the metrics. We get with the start time, the first bar, the last bar, duration, the return, if you just bought and hold, Sharpe ratio, Sortino ratio, Calmer ratio, all these metrics that we're going to talk in great detail about in our next, in one of my next videos. So that's how you can look at the summary of the results. So I guess I should have, I meant to write that here. Anyways, backtest performance metrics. I actually, for sake of completeness in the code, wrote down what these things mean, so you guys can go back and look at it. You can look at the individual trades, so you can do like summary, and I guess I actually ran it in a small set. Maybe I'll just run it on the whole data. I'll do the whole data set, and then you run the backtest here, bt.run. You look at the results that we saved in the summary variable. So how is this different? The return is still not that great, but now we have a lot more trades. We have 14 trades. Okay, so you get all these performance metrics here. And again, I'm going to talk about it a lot more in other videos. You can look at the individual trades because it has a dot trades thing here. So I can do dot trades. So the dot trades thing has like a size, entry bar, entry price, exit price, profit and loss, return percent, entry time, exit time, and duration. It's like first in, first out accounting. So like even if like your so basically like when you sell something, let's say you bought 100 and you double up and buy another 100, it'll sell the first 100 first. So like it will be a little different than you like expect sometimes. But most people do first in, first out. I actually played around with a lot of strategies like last in, last out for like try to get long-term capital gains tax in the US, but it never seems to work. Okay, so you can look at the plot. So these are the trades, right? Individual trades. You have the entry, exit, the P&L, and that sort of thing. The size. So if it's a short, it'll be negative. So this is a round trip. It's not like in interactive brokers where a trade is just one side. This is a whole round trip. Like this is, you start, you have an entry bar and exit bar until it closes. In other words, position is 0. So you can look at the plot by doing the first thing. This is not going to work. I know it's not going to work. I can do bt.plot, but it's not going to work because we have too much data. So I can do this. It's going to give me an error. It's going to say like too much candlesticks. Warning. So you can do resample equals true, equals false, sorry. And then you can get a plot. I actually don't really use the plots, but let me hyphen it out. But let me show you guys anyways, because I think a lot of people love plots. A lot of times it freezes your notebook, so that's a reason I actually don't use the plots usually. So you get a plot, you get, so the peak, it's hard to see, but the peak is here. The little blue thing, it's hard to see. The red is the max drawdown, that's the worst point, and the blue is the end of the data. These are your long trades, the greens and the short, the greens are your good trades, and the reds are your bad trades. So even if you're short, it'll be like and you win, it'll still be a green one. So let me show you. This is much more intuitive, this one. So what happens is here the green is a good trade. So you start at around like $100 here, I would say, maybe 110, and then it ends at about like what's the price here? Maybe one I don't know, 126 or something. So here you started at 103 and 126. So I couldn't see it 100%. So maybe here 103, somewhere here it's 103 and then 126 or so if you click the right thing. Okay, so that's one trade. But then the second trade we actually lost on the trade, right? So if you look here, the P&L for the second trade is negative, right? And if you see the second trade, what happens? Oops, it got all messed up. The second trade, we started at 113 and exited at 86, right? So, sorry, this thing got screwed up. Yeah, that's why I'm not a fan of these plots. Okay, you know what? Let's ignore this plot for now. I'll show you the next example in a second. So what you really should do, to be honest, if you really do want to use the plot, you should do bt.plot. resample equals false, you should save it to a file. So you should do like something like bt.plot resample equals false, and then you can give it a file name. You can do like file name equals sorry, my thing is freezing. You can do file name equals plot.html. That's a better way, I think, to do it. Oops, I should call it HTML. It's better to save it as HTML, especially if you're not using Collab, because you can just like download the file here, and then when you download the file, you can you go to downloads and you can open it, and it's easier to view. So remember, the second one I said it enters at about 122 to 125 and exits about like 86. So what happens is, let's look at our trade. We entered at, I guess, 113 and exited at 86. Does that make sense? Am I just not viewing it correctly? So 113. Oh, sorry about that, guys. Yeah, so you do enter at 113, because if you see the X and Y, the X says 113 above, and then you exited at 80. So it does correspond to the second trade. The third trade is a short sell. So it starts at 97 and then goes to 62. So even though it goes down like 97 or so here, and then 62 or so here, yeah, it's green because it's positive. It's a short sell that you covered lower. Okay, so that's the plots. I recommend using the HTML version, so saving it into a file. Okay, so now that we got that out of the way, let's talk about the main components of Backtesting.py. Okay, so the main thing is you have a strategy class. So in the strategy class is where we're gonna basically define our trading strategy. The strategy class has two methods we need to subclass. So the most important one is next. That means it's kind of trying to imitate when a new bar arrives, what the hell are we gonna do? So if like a new bar arrives and we have the 20 period moving average, 50 period moving average, if the 20 period crosses above the 50, we'll buy 100 shares. If the 20 period crosses below the 50 and we have a position, we close the position. So that's what the next method is doing. It's doing your trading logic with a bar arrives. It's trying to imitate a bar coming. The init knowledge, on the other hand, init method is where, let's say you have all these indicators you're calculating, you want to pre-compute it vectorized. Since we have the historical data, of course, we can pre-compute it vectorized. So like, let's say instead of computing the RSI every time a bar arrives, we compute one RSI vector. So we get like the RSI and 1 point at a time. And then it's just much faster for performance purposes. There is going to be another method later called self.I. It's like a magic backtesting.py method, which will magically work in the next method to give you just the latest point each time. So like, as I'm going to speak about here, there's these special class variables. There's self.data and self.I. So the big picture is the next method gives you the latest value one at a time with self.data and self.I. So self.data is with the data frame. So it's going to give you every time the next method gets called, every time a bar arrives, you're going to get the latest open, high, low, close volume for that bar. So you're going to keep getting one bar at a time, open, high, low, close volume with the next method. So that's self.data. And self.data is like a data type they have in backtesting.py. It's called this data thing here. And I'll go here actually to show you guys. So like you can go to a util. There's class data. So this is their data type. So it's kind of like a data frame, but not really. It has properties to get like the open, high, low, close volume. And it also has index to get like the date. So you should keep your date time as an index like I did above. And also it has a few like helper methods like df. So let's say like to calculate the indicators themselves, you need a data frame. So you can do like .df to get that into a data frame. Or .s, it has a thing def s here. So I'll do def s to get into series. I'll explain this in a second. I'll explain this in much more detail in a second. There's also similarly a self.I thing. And the self.I thing is like with technical indicators, the same as the self.data I explained above. So what happens is you wrap whatever function computes your indicator, like your RSI, your MACD, your moving average, your machine learning thing, and it's gonna compute for the whole vector, for your whole data set, the whole data set. But the self.I function is like a magical function, which when you call next, you only get one value at a time. So it's kind of trying to simulate what you have in real life. It doesn't obviously avoid leakage completely, because your whole indicator function could be can be like leaking one at a time, but it's like a way to simulate real life where like one at a time you get a new value. So that's important. I just wanted to make a small note that like the next method only starts when you have at least 2 bars without missing values. So let's say you have indicators based on 20, 30, and 50 bars, like let's say moving average 20, 30, and 50. The first 49 are going to be missing values. Only on 50 you're going to finally get a non-missing value. So the first next will have 51, because it only starts at when you have 2 non-missing values, and then the second next would have 52, and so on. Let me make all these things very crystal clear right now, okay? So I'm going to do that with a dummy strategy, okay? So just one little thing is, remember up here where we computed a RSI strategy, we had basically something where like we had our init, right? And the init, when we defined our backtest, we put the data. So the data here is a data frame, but once you put it in the data, it becomes backtesting.py's data type. So now we're in backtesting.py's data type, okay? So keep that in mind for a second. So now let me show you like dummy methods to illustrate the self.data and self.I concept. So let's just do like a dummy do nothing strategy to illustrate this. Okay, so like I can do something like import numpy as np. I can do def dummy indicator data return np.arrange length data. So this just gives me 0, 1, 2, 3 up to length of data. So that's my dummy indicator, and then I define my strategy class. So I can do class my do nothing strategy. It remembers my practice notebook. So I defined the init function. That's where I compute it. I want to show you first an example without computing using self.I. So I'm just going to do dummy indicator of self.data. So this is if you don't use self.I. And now I'm going to show you in the next method, self. I'm going to print indicator, dummy indicator. And remember, I did not use self.I here, just to show you an example. So if I print that, I'm going to print self.dummy indicator. And then for data, I'm going to do data.close. So I'm going to print self.data.close. And then I'm going to do print, I'll do data.index just to show you guys. Print self.data.index. And then we're going to run it for the first 10 of the data set. So now, let me show you guys. So now I can define my backtest itself. I'm going to do backtest equals backtest. And then I'm going to run it just for the first 10. And obviously, I'm not doing anything. I'm not buying, not selling, so I should have 0 trades. But just to give you guys like intuition. So, okay, see 0 trades. But then look one at a time what happens. Remember I said you only start when you have 2 non-missing values. So data.close has 2. Data.close now has 3. And similarly, data.index has 2 things. Data.index has 3. And then close has 4, index 4, all the way up to 10 and 10. So data.close has 10, data.index has 10. But the dummy indicator already has all 10 all the time. So that's not good. You can't get the latest value by doing like -1, right? So that's where the self.I comes in, right? So if we were to copy this whole thing, except now, see, we have self.I, we're going to have everything one at a time. So let me show you guys. So now I have this as here. So now what happens is I wrap the dummy indicator with the self.data, and now look what I get. I still get 0 trades, but now I get it, the indicator to do what the data itself does. So like you get the first 2, as in the first 2 here, the first 3, and so on. So that's what the magic self.I thing. When you have the dot next, it gives you just till the current point. So if you want the last point, you can basically do like I'll do like print dummy indicator last point. I can do print self.dummy indicator indicator -1, right? So let me just get rid of these for a second, just to show you guys. So now you get the last value one at a time. Okay, so that's the self.I and self.I and the data thing. Okay, so now like there are obviously indicators with more than one dimension. So like you're gonna need to return to use the self.I method something of dimension like a number of points in your data times anything, right? So like let me give you an example. So let's say we have like let's say we're gonna do like a Bollinger Band strategy, right? So we can basically do something like this. We can define the Bollinger Band. We can do like def b bands indicator data. And purposely, I'm going to make it wrong the first time. So if this was a pandas data frame, you would just do close equals data.close, the length of your Bollinger Bands. And iloc, I'll show you in a second. Let's get rid of the iloc for a second. Let's do it as is. So if I do b bands of, let's say, df.head, 10 won't work because you need at least 20. So let's do head 22. Let's make it actually easier. We'll do like a length is 5, right? So if I do head 10, what do I get? B bands indicator. I'm gonna get this. I'm gonna get something where it has like the first 4 are gonna be missing because your length is 5. You need at least 5 to compute it. And then you get the lower band, the middle band, the upper band, and then like these are ratios, how close you are to the middle, how close you are to the upper. So we want just the first 3 things because this is a pandas data frame, right? So at the end of the day, you have to return something that's like either NumPy compatible, that's dimension the size of your data set times anything. But like let's just return the first 3 here. So that's what we want here. Okay, but this is not going to work later because remember, I told you once you input it in the strategy or in the backtest your data frame, it becomes actually backtesting.py's data type. So then you're going to have to use the .s method if you want data.close to be a series. So I'll show you that in a second. So so basically, let's assume we're just going to do this B bands indicator the way it is. So I'm going to do something like let's just copy the same thing actually. I don't need to repeat it, but like just in case it'll be more understandable. So you define your indicator, and then we'll call it class. I guess we can still call it do nothing strategy, my do nothing strategy, and then its subclass is strategy, and then here we initialize it. Oops, sorry. Here we initialize it. We can do like def init, and then here is self.Bollinger Bands. But and I just want to show you that this doesn't work. So here, all I'm going to do is I'm going to do print self.bbands, and then def next. I'm going to basically I'm going to oh sorry, I wanted to do the strategy here. Okay, so I'm gonna basically I'm just gonna print. I'm gonna just print nothing. I'm gonna do pass here on the next, just to show you guys something. So like if I do this, and then I run the thing, I'm gonna get an error, because remember when you put in your backtesting, like you do bt equals backtest df.head my do nothing strategy. This df.head, this data frame, gets automatically converted into backtesting's data type. So it's no longer a series, and this thing accepts the series. So you're going to get an error. Watch this. Error. So that's why you have to use this thing. You have to do .s like this. And now you can run it. Okay. So you have to do .s. Okay. So that's how to get the data frame. But of course, we're gonna end up probably wanting the upper, lower, and middle. So as you see, this is the lower, middle, and upper. So you can do that by doing lower is the 0 actually. I don't know why default is like this. Lower is 0, middle seems to be 1, and then upper is 2. So middle, upper, and then I'll do 1, 2 like this. So these are the Bollinger Bands, right? And then you can get them one at a time by doing like print lower band, middle band, upper band, just to show you guys how it works. So as you see, like I'm printing it one at a time. So it only starts, that's weird. Because I printed it here. Okay, sorry guys. So now when the .next method, remember I said you have to start with at least 2 non-missing values. So the first one has a lower band of 2 here, 2, 2, 2. And then the next iteration has 3, 3, 3 for lower, middle, and upper, up until it has like this amount of not missing. Okay, great. So this is just the intuition on the self.I concept and the self.data. Now I'm going to show you how to do this to create like an actual strategy of like RSI B-band strategy. Okay, so we're going to create a strategy, and we're going to short if we're overbought, like meaning the RSI is above a certain number, and if we're above the upper Bollinger Band, and we're going to long if we're oversold, meaning the RSI is below a certain number and we're below the lower band, and we're going to close if we're in the middle band. So let's first do the init part, where we pre-compute the B band and RSI for computational efficiency, and we of course wrap it in the self.I, so when we use the self.next we can do it one at a time. So let me show you guys how to do that. So so first let's calculate our, let's say, def RSI indicator, and then this takes data, and then what are we going to need to return? We're going to need to return ta.rsi. Let's do the default 14 period. Here I did .s to make this a series again. So this is the RSI indicator. What else do we need? We need the B band indicator as above, right? Band indicator. And now ta.b bands. Remember we did iloc like this. Is that what we did? We should probably just copy it. Okay, but we're going to use the default. We're not going to make it 5 period. We're going to make it 20 period. So B band's indicator will be like this. Okay, so we're going to make it 20 period. Okay, so now we have the RSI indicator and our B band indicator. So we're going to subclass strategy. So we're going to do RSI B band strategy, subclass strategy. And then this is going to be our init. So diff init, self. And this is where we compute the things. We do self.b bands equals that, and then self.upper. It always messes these things up. So let's just do it in order. It goes lower, middle, upper. So got the middle part right. So self.middle is 1, but it got the upper wrong. So let's flip these guys. And then RSI here, self.RSI. And then of course we wrapped it in I, so you get things one at a time. Okay, so this is the RSI B-band strategy, and let's just do for next, let's just print this to show you that it computes everything right away. So we'll do print self.bbbands.shape, print, I'll write B-bands shape. This is the pre-computed, and then I'll print here RSI shape. The pre-computed does everything, even though the .next does it one at a time. I probably repeated myself way too much. Self.RSI.shape. Okay, great. So now that's the init method. Oh, and we're gonna want oversold and overbought thresholds. So let's add them here. You actually probably want to add it here because later, if you want to use the optimized method for backtesting.py, that's where you have to define it above the init. So you can do like overbought thresh, oversold thresh, and then neutral thresh, something like that. And then def next, we're gonna just do a dummy thing that's not gonna do anything, and I'll do pass. So then I can define my backtest just to see if it works. I can do bt equals backtest, df.head, RSI strategy, bt.run. I should get basically no trades, and it gives me the shape 3 by 1,000 and 1,000. Okay, great. So that's what we want. So now let's actually add our trading logic to it, the next part, right? So the next part, what do we want? We want to do, what do we want? We want if it's oversold. So, okay, it's given me crossover as like a idea, but let's, let's do it without the crossover for a second. So if RSI is greater than or is less than or equal to the oversold threshold, the last RSI, and the position is not you have no position and you have no open orders. We don't need this no open orders thing if we don't have if we're just doing like a market order. So I'll get into these concepts in a second. So like basically if the RSI is below the oversold threshold, then we're gonna buy. And we also wanted the B band thing. We wanted the basically self.data.close -1. We wanted this to be we wanted the self dot lower band -1 to be less than or equal to the last close, right? So that's when you buy, and then you sell when it's overbought and you're above the upper band. So and I have this no position thing because we don't want to duplicate in this example. So we do self dot data, and the reason I'm doing in this order will become apparent in a second. So I actually want to do self dot RSI -1 greater than or equal to self dot overbought threshold. And the reason this order will be apparent in a second. So, and no position and self.data.close -1 is greater than or equal to self.upper band. So that's when you short if you have no position. Upper band -1. Okay, so great. So that's this. And then we have two more conditions to close things. We have elif self.position is long. So you have a long position and the close goes above the middle band. That's when we're going to close our position. So position is long means you're long, and elif position is short, and the close goes below the middle band. We're going to close the position. Okay, so let's run this strategy and see how it does for a second. Okay, so I printed the things at first. See, the return is this. It does worse than buy and hold by far. Negative return, but just to show you the example. Okay, so that's this strategy, right? And it does 774 trades, so it trades like a lunatic. In a lot of the examples, you actually see them use this crossover method. So by the way, to get what a function does, you can do question mark crossover. So you do question mark crossover, you see, what does the crossover thing do? It says this is true when series 1 just crossed above series 2. So if you look at the code, it means series 1's -2 is below, the second to last index is below, and the last index finally goes above. So it's when a cross happens. So let's try to actually use that method, the crossover method. So we can rewrite this whole thing with the crossover method, because I think that's just more proper for that algorithm. So let's do crossover, and that's why I kept it in this order, because it's when this thing crosses this thing. So I'll do crossover, this, like this, self.RSI, and then I'll do crossover like this, overbought threshold, and I'll do crossover here. It's like Allen Iverson, all these crossovers, if you guys like basketball. So this is when the lower band goes above the close, right? Meaning the Yeah, so that makes sense. And then cross over here. So if you guys like Allen Iverson, this is a good strategy for you. Okay, so this is just using their crossover method. And similarly here we have the crossover. So here we're going to close when the data set, the dot close, goes above the middle band. That's when we're going to close our long. And similarly for short, when the data goes below the middle band. Okay, great. So now we get our thing. I don't know if it's going to influence the results much, but let's just run it anyway. We got one trade. That's weird. Why did we get one trade only? It's weird. Hey, the return is better, but we got one trade. Maybe I messed up on something. When the close, you have to go like this. I don't know if that's going to fix it, but anyways, that's not the point of this video. See, number of trade is 549. We get a return of still negative, so it's not a good strategy. Not saying it's not a good strategy, but like in this case, it does way worse than buy and hold. So this just has a few concepts that I want to talk about. So like I want to talk about the ordering. So it has a buy. You can have a buy, you have a size, and you have a sell, and you have a size. But you can also add to these things like a limit. You can add a limit. You can add a stop loss, and you can add a take profit. So you can add those things. That's also why it's useful. So yeah, you can add a limit, take profit, and a stop loss to both the buy and the sell. And also there's this position.close thing. The position thing is useful because if you don't use it, you can sometimes have overbought. Like you can buy things a few times in a row if you don't close your position, or if you like do the opposite thing like dot sell. So it's like a handy thing to have. But the big picture is the ordering has buy and sell. You can do a limit, you can do take profit and stop loss. By default, if you don't have like a limit, the market order occurs at next bars open. That's the price for the market price. For the limit, you look at the next bar and you have to see if it's a buy order that the next bar has a low below the limit. Of course, I said there's an issue when you have like conflict between like the stop loss is also below the low price. So how do you know that the limit happened first before the stop loss, or how do you know like the limit happened before the take profit? So you can look at the code, but Backtesting.py seems to take the pessimistic approach, as we spoke about above. So I think the assumption is it takes the worst approach. So basically, what I would do is I would try to like run the strategy, get some intuition, and then join your data set with like maybe 5-second data and get like a little bit more granular result if you need that. The other thing that was important is you have this dot position method, right? So that position has things like you can close a position with self.position.close. Like I said, it's very useful for not over trading. You don't want to like, instead of you buy something and then sell and then you sell again, you don't oversell, overbuy. And then it has all these helper methods like is long, is short, meaning are we net long in the position, net short, and you get the position size. And so let me just show you guys like an example of like, we'll do the same example as here, except now we're going to add a stop loss, take profit, and a limit. The stop loss will be $1 more. The take profit will be the limit will be the closing price. The take profit will be $1 more, and the stop loss will be $1 less. So all we do here is we do like limit equals self.data.close minus 1. I don't know why the autocomplete did that. And then I'm going to do a take profit. Going to be TP equals self.data.close minus 1 plus 1. Stop loss $1 less. And then for sell, we're going to do something similar. The limit is going to be self.data.close minus 1. take profit is going to be one higher, one less because we're shorting, and then the stop loss is one more because we're short. But now we need to add a condition. We need to add and not self.orders, because what happens here is, in theory, the next bar can be a gap up, and you can, in theory, you can never get the limit you set, right? And so the limit will not hit, right? Especially if your limit is less than the closing price. Like your limit is like 50 cents less, it can never hit. So you can actually now just buy things like have like 10 buy orders in a row, and that's a bad thing. So you should do not self.orders. And in a second, when I talk about trade management, I'll also talk about self.orders. I'm speaking a million miles an hour, but the video is already long, so that's why. So now we can run it. It's like a similar strategy, and let's see how it does. I know this is probably not going to be so good. So as you see, like it's not that great. So let's just, as another example, let's do something where we only sell for at least $1 more, because I want to illustrate a concept for a second. So let's say like let's remove shorting. We don't want to short, so I'll remove this, and I will also remove is short here, because we're never going to be short. But what I want to do here now is something else. I want to do like I'm going to buy something, and let's say I'll only sell if it's $1 more. So what happened here is I closed the position no matter what, but I actually only want to sell if it's $1 more. So now what's going to happen is I'm going to okay, so I'm going to still have the same buy condition, but the selling condition, I want to sell at least $1 more than what I bought. So I'm going to have like some variable. We don't need this here. Let's have some variable, like let's say self dot last buy price, and let's make it none. And then whenever you buy, you're going to have this as like self dot buy price equals self dot data dot close minus 1, and then this will be self dot buy price, and then this take profit will be self dot buy price plus 1. It's the same thing, except I'm storing it in the buy price variable. Buy price minus 1. Okay, great. So this is where I buy. But let's say I only want to close if I win the trade, like bag hold forever. So here, instead of position not close, I'm going to have to do self.sell. And the sell, what I'm going to have to do is I'm going to have to sell the same size is 100, and limit will be self.buy price plus 1, right? So that's what I want to sell at. When there's a crossover, I want to sell at a limit price, at least $1 up more, right? So if I do it just like this, there's a problem, right? Because if I do it like this thing can hit many times, and you can oversell, right? So I also have to have if I have no orders, I need no open orders, okay? Because I'll explain in a second, but you also need this no open orders thing, and that will do this thing. But I want to show you guys what happens here. So you have 301 trades. Soon I'm going to get to order management, I promise. So like I look at the summary. Let's look at the actual trades. Look at what happens. So you're going to end up being stuck with a trade, and it's going to automatically close it at the last bar. It's weird. Sorry guys, I must have the autocorrect must have messed me up. What I want is the auto thing. I want self.sell size is 100. It literally did what I wanted it not to do. Limit equals self.buy price plus 1, $1 more, right? So I run the strategy, and I'm gonna lose a trade at some point. So what's gonna happen? By the way, I get this warning that you have a stop loss take profit, and if it executes the same bar, it was turned into a trade, but you can't assert intra candle movement. This is the thing I showed you a lot of times, is you don't know if the stop loss, the take profit, or whatever happened first. But now let's look at the trades. So obviously you're going to lose a trade, right? Because no one's perfect. So why is it not working again? Kind of weird. Oh, because I have a stop loss. Sorry, guys. I don't want a stop loss. I want to always win in this example, right? Okay. So look what happens is eventually you're going to lose, right? So you're going to bag hold. So like this one has 155 days, right? So like you're not going to always be able to win a trade, right? So like, because this one's $1 more. So as you see, it's 155 days, but the system closes it at the end. It like basically assumes if you have open positions, it closes it at the last bar. So that's what I wanted to show you. So if you have a strategy that you want it to win for sure, so you have like the limit $1 more, it closes it at the end. So here you see we're going to have things that are a lot more days, like 16 days, because it waits until you're up by $1. Okay, so wow, how long are we in? We're already 51 minutes in, so let's try to go pretty fast. Okay, so so now let's talk about trade management. So trade management is basically something that I don't see talked about as much in some of the other backtesting videos, but you can actually get to your orders. You can get to like open orders with self.orders. 1 second, my camera apparently isn't showing me that well. You can't see my Michael Jordan jersey. Let's try to fix that for a second. Okay, great. The point is not for you to see my Michael Jordan jersey, but to see me a little better. Okay, great. Okay, so trade management. So here is like when you want to see your orders, you want to like see your trades within the actual backtesting, right? So like let's say you want to cancel order if something doesn't work out, or you want to look at your trades to get like the last fill price if you did a market order, or or like things like that. So there are three main things that backtesting.py gives you. Self.orders gives you basically orders that have that are in progress, have not been filled yet, and orders has also a thing called cancel orders where you can cancel the order. And let's say like order has not been filled and you want to change the limit price. The best approach is to cancel the order and resubmit the order according to the documentation. So self.trades is where you can access like your not yet finished round trip trades. So let's say you buy 100 and you have like a take profit instead. Let's say you buy 100, right? Once the first buy is filled, that will be when self.trades populates. But then when you close the position, the next 100 is sold. The 100 is sold. That's when self.trades you get rid of that trade and it goes into the close trade. So trade is only when you have one side still open. And I'll make this crystal clear in this example. So this is an example where every time I'm going to basically print what happens until I get a trade and how it looks like. So I start with no trades, no trades, no trades, no trades, no trades. Eventually, I make a trade, right? I place an order, right? So then in the next bar, what happens is, I place the order, and in the current bar, I have the order, but I have no trades. And I say end current bar. So I just have orders. And then in the next bar, I have orders. These are the orders. And then the order is filled in the next bar because it's a market order. So the first open of the next bar. And then trades, you have a trade here. But you don't have a close trade because you just bought it. You didn't sell it. You didn't close your position. So like you have trades, you always have closed trades is nothing. Orders, I'm assuming you only bought one time, so orders is always nothing. And then at the end, finally, what you get is you get once you close your position, the trades thing becomes nothing now, and the closed trades adds the trades once you finish a round trip. So that's the orders, the trades, and the closed trades. Okay, so another question is, what if you have partial orders? So like, let's say if I, instead of selling all 100 here, I sold just 20. So what happens is you'll end up having two columns. One will have trades with trade size 80 because you have 80 left, and one will have trade size is 20 for closed. That's what happens with partial orders. So this example, instead of doing dot close, I basically sell 10. So I'm going to sell 10 two times just to show you guys. So the first one will have completed trades 10, but dot trades is 90, and the second will have completed trades 80, dot trades is 20. So let me show you guys how that looks. So like if you look at the end, what I said in the two examples is like, okay, here, okay, so here you still have the full trades, right? And then once you close the trade, you sell 10, you have 90 and 10. You have both of them still open, and then you have 80 and 20 at the last one. Only when this thing goes to 0, it fills in the closed trades. That's the default behavior. So let me show you guys, like this video is running a little long. So you can close your orders, for example. So I can do like a class, my closing, you can cancel orders, sorry. My cancel orders strategy in G. For example, you can cancel orders. So how am I going to do that? Just a second, sorry. Wow, we really went over time. Sorry guys, just 1 second. Okay, so let's just make a dumb cancel order strategy. As I wrote here, we're going to basically cancel, we're going to have a cancel order at the next bar. And the next bar after we place it, and we're going to place the limit order $2 if a random number is less than 0.1. Okay, so how are we going to do that? So we're going to basically do something like our init method. We can have something like, first of all, let's set our random seed, because I want to do this random thing. Random dot seed is 1 just to save the thing. I guess 42 is usually the default. I'll have something called just bought, because I don't want to print everything to make it a little bit more readable. False. So what happens here is this is just going to be a stupid strategy where I'm going to basically do like basically what's going to happen in this strategy is I'm going to do if np .random.rand less than or equal to 0.1, and I'm not worried about positions or orders. I'm just gonna basically buy 100 shares, right? And I'll throw in some limit price of $2 below, okay? Just to show you guys. Okay, but then also I want every time a new bar arrives, I just want to cancel the order. So if I say so basically if just bought, and then I'll set here self.justBought equals true. So I'll do if self.justBought. I'm gonna cancel orders. So I'll do print canceling orders, and then I'll do for order in self.orders order.cancel. So basically this cancels it the bar after I go in. If we just bought. If this is false, self.justBought is going to be false. Just bought equals false. So then I can run the backtest here. I'll do it on the full data set, I think is a good idea. So I'll do this, and let's see how it looks like. So here it cancels orders, but no, it cancels it in the next bar. So it's definitely possible you got filled. So here, for example, you did 28 trades because you didn't cancel it in time, because like let's say it could be that it doesn't know like what happens first. Like the limit price hit first, so it assumes the limit hit, so you didn't cancel it in time. If I were to, for the sake of comparison, just put the canceling here, no matter what, you'll see I'll get 0 trades. So I'll do like to get 0 trades, we cancel immediately. So this is something good to know because it's how the framework handles the situation. Maybe I shouldn't print it every time, but see, this gives you 0 orders. Okay, so let's just do the other thing where we're canceling it at the next bar, because I want to say like if we didn't cancel, what's the difference? So here we do cancel at the next bar. As I showed you, we have 28 trades. And it's funny, our return is actually better with the random strategy. Our return is better than the RSI Bollinger Band strategy above, right? So that's interesting. So like now, what if we don't cancel? Just to show you guys the difference, I'll say like don't cancel order strategy. Just to show you guys that it actually it has a way more orders, because most of them are not canceled. Well, actually, eventually you run out of money, so it can't have that many more orders. But it has more than 28. So let's see what it gives us. Okay. And once that's running, the last thing is I want to show you how to change the take profit and stop loss. So it's another mess of a situation. So while this is for some reason still running, let's just do this like class change take profit stop loss strategy. This will be like a dummy strategy where I'm gonna have basically a market order, and I'm just gonna show you how to change this take profit and stop loss, just to something that's like unreachable kind of. So well, it is reachable because the way it handles things is like if it reached it before you change it, it filled. So, but here you see in this example it had 115 trades when we didn't cancel. But here, the example of changing the take profit and stop loss, we could do something like I'll do like changed take profit stop loss, just to make it equals false equals false. So I'm going to have something like, I'm literally going to just buy no matter what, self.buy 100. I'm going to have a take profit. You know what? Let's have something like this. Something where it's like take profit is $5 more and stop loss is $5 less. Let's do 15. Okay. So this is something that will eventually hit, right? In theory, right? But you know, let's only do one order. Self.ordered equals false. Okay. So if not self.ordered, if we've never ordered yet, let's buy 100, but with the take profit 15 more and the stop loss 15 less, and eventually this will get filled. The AMD's moved more than $15, right? But I want to show you how to like change the take profit to stop loss. So, okay, so I'll do I'll have a variable here like self.justOrdered. Ordered equals true. Self.justOrdered equals true, and then I'll do like if self.justOrdered. Then I'm gonna change the take profit and stop loss. So I'll do for trade in self.trades trade.TP equals, let's say, this crazy number. Trade.SL equals 0.01. So this will not, this will guarantee I only have one trade and it'll close at the end. So now let's run this stupid strategy. I'll do BT equals backtest. Wow, I didn't realize this will take so long to do this video. So so I run this backtest. I only get one result. So I buy, size is 100. Okay, so now I changed it one time, if just ordered. I'll do print change TP stop loss. So let's run it. Oh, why does it run one time? Oh, oops. Let's do else self.just_ordered equals false, and self.ordered here it will make it true equals true. Oops. So this is just showing you how like you can modify your like take profit and stop loss. So here like I changed it in a way where you're never gonna have you're only gonna have one trade, right? So actually that's weird. Oh, it's not the same as buy and hold. Why is it not the same as buy and hold? Because this takes it at the next bar. So that's a weird. But like if you look at our actual trades, remember it takes it. You have actually it takes it at the next open. So as an exercise, I wanted you guys to realize why is this not the same? If this is only making one trade, it's buying at the first thing. So actually, it takes it 2 bars ahead because this only happens when you have 3 bars ahead, 2 non-missing values, and then it happens at the open of the third value. So that's how you can reconcile these things. But I'll leave it as an exercise. But just to show you guys, if I do summary.trades, and I went way overboard with time, you'll see, oh, I didn't save it, sorry. Summary. You'll see I only have one trade that enters at like the first bar. So it's entry bar 2 because I said it starts with 2 and exits at the last bar, and then you get your P&L. Okay, so anyways, so we'll talk about more advanced things in the next video. How to lower your average, position strategies, optimizing parameters, the walk forward method. Very importantly, the dangers of backtesting, and we'll create a one-to-one map with interactive brokers trading. And of course, I'm open to more suggestions. If this long video wasn't so boring, please like and subscribe. Thank you guys so much, and see you in the next video. Peace.